Hi there. This is a realistic DevOps interview simulation focused on one of the hardest situations you will face in production. Something is broken, users are complaining, and you have little to no logs to work with. I will ask the questions the way they are asked in real interviews, and after each one, I will give a strong sample answer so you can compare your thinking. Before you listen to the answers, pause the video and answer each question out loud as if you were in the interview. That is where the learning actually happens. If you want more interviews like this covering real production problems, subscribe so you do not miss the next one. Warm-up behavioral questions. Tell me about a time you were responsible for debugging a production issue with very limited information. A strong answer here starts by acknowledging the uncertainty instead of trying to sound heroic. I would say something like this. In one incident, alerts showed elevated error rates and latency, but logs were either missing or incomplete due to a logging misconfiguration. I focused first on understanding impact and stabilizing the system. I checked recent deployments, infrastructure changes, and traffic patterns to narrow down what could have changed. At the same time, I communicated clearly with stakeholders about what we knew and what we did not know. Once the system was stable, we fixed the logging gap and documented the incident so the same blind spot would not happen again. How do you stay calm when production is failing and you do not have the data you expect? A good answer shows emotional control and structure. I try to slow myself down mentally and focus on first principles. Panic usually makes things worse. I remind myself that even without logs, the system is still giving signals through metrics, behavior, and user reports. I also lean on process. I define a clear next step, validate it, then move on. That structure keeps me calm and prevents random guessing. Describe a situation where you had to make a decision with incomplete information that affected production. Here, I would talk about trade-offs. In one case, we had a partial outage and no clear root cause yet. We had to decide whether to roll back a recent change or keep digging. Based on timing and blast radius, I recommended a rollback to reduce user impact, even though we were not 100% sure it was the cause. That decision restored service quickly. Later analysis confirmed it was the right call. The key was prioritizing user impact over being perfectly certain. How do you communicate uncertainty to non-technical stakeholders during an incident? A strong answer avoids jargon. I usually explain what we know, what we suspect, and what we are doing next. I avoid speculation presented as fact. I might say something like, we are seeing elevated errors starting at this time. We do not yet have logs to confirm the root cause, and our current action is to reduce load and isolate recent changes. Clear updates build trust even when answers are incomplete. Core technical and scenario questions. Imagine production traffic is failing intermittently, but application logs are unavailable. Where do you start? I would start by treating the system as a black box and observing its external behavior. I look at metrics first. Error rates, latency, saturation, and throughput tell a story even without logs. I check whether failures correlate with load, specific regions, or specific endpoints. From there, I look at recent changes, deployments, config updates, scaling events, or infrastructure maintenance. Even without logs, change history is often the biggest clue. I also try to reproduce the issue through synthetic requests or canary traffic to see patterns. What signals can you rely on when logs are missing or unreliable? Metrics become the primary signal. Things like CPU throttling, memory pressure, queue depth, connection counts, and retry rates can hint at what is failing. Traces, if available, are extremely valuable because they show where time is being spent even when logs are absent. Outside the system, user reports and client-side metrics can also be signals. Sometimes the absence of expected behavior is itself a clue. How would you debug a memory leak in production without application logs? I would focus on resource behavior over time. I would look at memory usage trends per instance or pod to see if usage grows steadily and never drops. I would correlate that with traffic patterns to rule out simple load increases. If possible, I would compare a healthy instance with a problematic one. Even without logs, tools like heap metrics, container restarts, and kill events can confirm a leak pattern. From there, mitigation might involve restarting instances on a schedule or scaling out while planning a proper fix. If you suspect a dependency is failing, but you have no logs confirming it, how do you validate that? I would look for indirect evidence. Increased latency waiting on outbound calls, elevated retry counts, or timeouts are common signals. I might temporarily add circuit breakers or reduce dependency usage to see if the system stabilizes. If the system improves when a dependency is isolated, that strongly suggests where the problem lies. In interviews, I always explain that validation does not always mean proof. It often means reducing uncertainty enough to act safely. What mistakes do engineers often make when debugging without logs? The biggest mistake is guessing instead of observing. Without logs, people tend to jump to conclusions based on intuition. Another mistake is changing too many things at once, which destroys signal. A strong approach is making one controlled change, observing the result, and then deciding the next step. Interviews look for that discipline more than deep tool knowledge. How do you prevent being in this situation again after the incident is resolved? I would talk about improving observability as part of the post-incident work. That might mean fixing logging pipelines, adding missing metrics, improving tracing coverage, or defining better alerts. I would also document what signals were missing during the incident and turn those gaps into action items. The goal is not just fixing the bug, but reducing future debugging time when things inevitably fail again. You have an outage affecting only a subset of users, but logs are missing and metrics look mostly normal. How do you approach narrowing down the problem? I would start by reframing the problem from what is broken to who is affected. Partial impact usually means there is some kind of segmentation happening. That could be geography, availability zone, user cohort, feature flag, or even a specific client version. I would look at request patterns by region, instance, or upstream dependency and try to find where the failures cluster. Even if metrics look normal globally, breaking them down often reveals skew. Once I identify a boundary where behavior changes, that boundary becomes my main investigative surface. Let's say latency is spiking, but CPU and memory are fine and you have no logs. What are you thinking about next? When resource usage looks healthy but latency is high, I usually suspect waiting. That could be waiting on I/O, waiting on a downstream service, or waiting on locks or queues. I would check things like connection pool saturation, thread pool usage, request queue depth, and retry behavior. Even without logs, metrics around waiting time tell you whether work is blocked rather than slow. If nothing obvious shows up, I would consider network-level issues or DNS resolution problems, which often do not show up as CPU or memory pressure. How do you safely introduce new visibility during an active incident when logs are missing? This is a place where interviews often test judgment. My first question is always whether adding visibility could make things worse. If the system is already stressed, turning on verbose logging could increase load and amplify the outage. I would prefer lightweight options first. That might be enabling a single metric, adding sampling to traces, or temporarily increasing visibility on one instance instead of all of them. If I do add logging, I do it surgically and with a rollback plan. The goal is learning without destabilizing the system further. Imagine a system where requests are failing, but retries are masking the failures from your dashboards. How do you detect and reason about that without logs? Retries are tricky because they can make everything look green while users suffer. I would look for indirect signals like elevated retry counts, increased tail latency, or higher than normal request volume compared to user traffic. If the same user action is generating multiple backend calls, something is being retried. I also look at error budgets and client-side metrics if available. In interviews, I explain that retries improve resilience but also hide problems, so observability needs to account for both success and effort. How would you debug a data inconsistency issue in production with no logs and limited database visibility? I would first confirm whether the inconsistency is real or perceived. That means comparing read paths, caches, and replicas to see where data diverges. I would check whether reads are coming from different replicas or regions and whether replication lag could explain the behavior. Without logs, I rely heavily on timestamps, versioning, and checksums if they exist. If the system allows it, I might introduce a controlled write and observe how it propagates. The key is reducing the problem from all data to a small testable slice. You suspect a recent deployment caused the issue, but there is no direct evidence. How do you decide whether to roll back? I look at timing, blast radius, and reversibility. If the issue started shortly after a deploy and the deploy is easy to undo, rollback is often the fastest way to reduce impact even without proof. If rollback is risky or slow, I may choose to mitigate first by reducing traffic, disabling features, or scaling differently while continuing investigation. In interviews, I always emphasize that rollback is a tool, not an admission of failure. The decision is about restoring service, not being right. What is your mental model when debugging without logs? I think of the system as a set of constraints and signals. Something must be waiting, failing, or misrouted. Even without logs, the system cannot hide all evidence of that. Metrics, timing, topology, and recent changes form a narrative. I try to validate or invalidate hypotheses one by one, not by guessing, but by observing how the system responds to small, controlled actions. That mindset is what keeps debugging productive even when visibility is poor. How do you know when to stop debugging and focus purely on mitigation? I stop deep debugging when continued investigation risks increasing user impact or slowing recovery. If users are still affected and I have a mitigation that reduces harm, I prioritize that. Once the system is stable, debugging becomes easier and safer. Strong candidates explain that incident response has phases. First stabilize, then understand. Mixing those phases often makes both worse. What lessons do you take from incidents where logs were missing? The biggest lesson is that missing logs are rarely the root cause. They are a multiplier. They turn small issues into long incidents. After recovery, I focus on why logs were missing, whether it was configuration drift, cost cutting, or poor defaults. I also push for multiple layers of observability so that losing one signal does not leave us blind. Interviews like to hear that you think beyond the incident and improve the system itself. Pressure and judgment. Questions. You are in the middle of an incident. Users are complaining loudly. Executives are asking for updates. You still have no logs and only partial signals. What do you prioritize in the next 15 minutes? In that moment, I prioritize two things in parallel. First, I reduce user impact as quickly as possible, even if I do not fully understand the root cause. That might mean shedding load, disabling a feature, or routing traffic away from a suspected dependency. Second, I establish a clear communication rhythm. I make sure stakeholders know what we are doing, what we do not know yet, and when they can expect the next update. The mistake under pressure is to chase certainty. The right move is to stabilize and buy time. Imagine a teammate wants to restart everything because it might fix the issue, but you worry it could erase useful signals. How do you decide? I pause and assess the cost of losing state versus the potential benefit. If the system is already unstable and restarts could worsen the outage, I push back and explain why. If restarts are low risk and could reset bad state, I may approve them, but in a controlled way, like one instance at a time. The key is making the decision explicit. I say out loud what we gain and what we lose. That keeps the team aligned and avoids emotional decisions under stress. You are asked to give a root cause estimate, but you genuinely do not know yet. How do you respond? I am honest without being vague. I explain what hypotheses we are exploring and what evidence we are waiting for. I avoid guessing because guesses tend to stick and become perceived truth. I also set expectations by saying when we will know more. Leaders usually handle uncertainty better than silence. Calm transparency builds trust, especially during messy incidents. There is pressure to add debug logging immediately, but you suspect it could overload the system. What do? I treat observability changes as production changes. I evaluate whether the added load could push the system over a tipping point. If there is real risk, I suggest alternatives like sampling, enabling it on a single instance, or waiting until traffic is reduced. Under pressure, doing something feels better than doing nothing, but unsafe actions often extend outages. I frame my recommendation around protecting users first, not around being cautious for its own sake. After the incident, leadership asks why the system was so hard to debug without logs. How do you answer without blaming the team? I focus on systems, not people. I explain how the lack of logs increased time to recovery and what design or operational choices led there. Then I propose concrete improvements, like baseline logging, better defaults, or guardrails that prevent logs from being disabled silently. The goal is learning, not defending. A mature response shows that incidents are opportunities to strengthen the system. That brings us to the end of this interview simulation. Production debugging without logs is one of those situations that separates theoretical knowledge from real-world experience. There are no perfect answers, only better and worse decisions under pressure. As you reflect on what you heard, think about which question made you uncomfortable or forced you to slow down. That is usually the one worth practicing. Was it deciding when to roll back, communicating uncertainty, or choosing between mitigation and investigation? If you are preparing for DevOps, SRE, or platform interviews, pause the video, replay the hardest question, and answer it out loud as if you were in the room. That habit builds confidence far more than memorizing definitions. If you want more interviews like this one, covering real production scenarios and judgment calls, subscribe for the next session, and let me know in the comments which question challenged you the most.